Hi guys, welcome back. So as I said, we are going to apply all these properties that we've spoken about when it comes to triangles and the classification of triangles, and try to use those relationships in trying to prove certain things or certain relationships of angles. So let's just jump into it right away. So what I want you first to think about is we have what we call bisect a line, right? To bisect simply means to cut in half, right? So if I say that AB is bisected, I simply mean that at this point, which I will call M, it makes AM to be equals to MB, right? MB. That's what bisected means. And then bisect an angle also would simply mean the very same thing. It is to cut in half. But now what that means is if I have A, B, C, and I say that B is bisected, that will introduce something of this nature, right? Where this angle is equals to that angle because it is bisected, right? So that's what you need to think about, please. And then lastly, we have what we call bisectors. These will be the lines that cut the sides or angles in half. Right, so if I say this is an angle bisector, I'm saying that's a line that cuts those angles to be into two equal parts. Now, let's try and apply all of this that we've spoken about. If I say QR is parallel to ST, right, I'm not even going to continue with anything there because I'm now interested in what does this do for me on the diagram. Why is it important that I know that, right? What information will it introduce for me? What I know is this will introduce the fact that this is going to be equals to that there, and the reason for that will be alternate angles, right? And also, I will know that I can say this part here, which is W2, is equals to this part there, right, which is corresponding angles. I can talk about more things, right? I can talk about co-interior angles that I have, all of those things. I also know that I'm told WA and ZA are bisectors of QWZ and SZW. So let's start with the first one, Q. Let me just use a different color. QWZ, right? It makes this angle to be equal to that angle there. I'm going to show you in the next slide on a clean diagram. And then SZW will make this angle, right, to be equals to this angle. So I'm making it a cross and a dot so that it does not make it look like I'm saying all of them are now equal. Also, I know that I'm required to prove that A is equals to 90 degrees, which is this angle there. So let's talk about this. We feel what we are given on the diagram, and that's what I will know based on everything that I've spoken about. To use all of this now, I will then now say A plus Z, right, plus W5 is equals to 180 degrees. Let's quickly go there and find out why, right? This angle of A, that angle there, and this angle there. If I add all of them, they will give me 180 degrees. Why? Because it's interior angles of a triangle. So this will be interior angles of a triangle, right? Or rather, sum of angles in a triangle. And then now I want to try and talk about all of this and see, what do I now know? I know that W2 plus, oh, not W2, W1 rather, W1 plus W5 plus Z1 plus Z2, this is equals to 180 degrees. And this is because of co-interior angles. Why? Because I know that QR is parallel to ST, right? So as a result, I can equate these two. By saying that since they are both equal to 180, it means that A plus Z2 plus W5 will be equals to W1 plus W5 plus Z1 plus Z2. I hope you can follow everything that I am saying here, right? Let me just fix my Z so that you can see them clearly. This must be a Z. What else? That one, that one. So let me just write them properly for you. So that is a Z and that is a Z. So others are a bit clearer. Now, what do I know? Based on this, I know that there is Z2 there, there is Z2 there. There is W5 there, there is W5 there, right? Therefore, as a result, I will be left with A is equals to W1 plus Z1. Z1, right? But now, going back to our diagram, what do we know? We know that W1 is the same as W1 is the same as W5. And we also know that Z1 is the same as Z2. So what that tells me is this will be A is equals to 180 degrees, right? Divided by 2. Because of the fact that Z1 is the same as Z2 and W5 is the same as W1. So I can then say I have 2 of that in order to make sure that I understand what I am trying to do here, right? So that's what I can then say, and that's how I can try and prove this. Now, one more example of how we can use all of this that we've spoken about so far. I am told that CD and BD are bisectors of the exterior angle ACE. That makes this to be equal to that. And then the interior angle ABC of the triangle ABC, right? So the interior angle ABC making this to be equals to that there. Please see that I'm trying to show them with different symbols so that they are equal. Now I'm required to prove that D is equals to half of A. But first, I add all the information that I know, and then I'm going to apply that by using the deductive reasoning. So now what do I know? I know that C3, right, C3 is equals to D plus B2, right? And this will be because it is an exterior angle of a triangle, right? And then I will say D is equals to C3 minus B2. And then also, what do I know? I know that C2 plus C3 is equals to A plus B1 plus B2, right? And this is also an exterior angle of a triangle. Based on that, I can then now claim that wherever I see my C3, I substitute it with D, right? With D plus B2, right? So this will be C2 plus, here it will be D plus B2, which is equals to A plus B1 plus B2 2. I just substituted there. And then B2 and B2, you know they're going to cancel there. And now what do I know? I know that based on this C and the A and the B, they must have a certain relationship with one another, right? And here's my C2 here. I'm trying to relate it to the angle A and the angle B1. Angle B1 there, right? So these two angles there, I'm trying to relate it to this angle C2 there. And as a result, that will make me to have D to be equals to A plus B1 plus a minus C2, I mean, minus C2, right? So if I minus C2 from A and B, that will only give me, and B1, that will only give me A alone and half of it, by the way. So therefore this will be D is equals to half of A, based on the fact that these two angles, if I was to subtract them, remember the deductive reasoning, if I subtract them from those two angles, it will be like half of that, which is this one here. And that's how I can then talk about these particular angles. All right, guys, we've come to the end of our show. I hope you've learned a lot, and I really, really have enjoyed doing this because geometry is so nice that you can visually see what you're talking about. But really, everything that is nice always needs to come to an end. I will see you guys next time. Remember, mathematics is food for the soul.